It would be so easy to discuss the Acorn Electron in the shadow of its big brother, the BBC Micro. To assess what it's lacking as opposed to what it has, and to dismiss it in favour of the more popular 8-bit micros of the time. But for this neglected elk, it's time to shine, to tell its story, and to stand on its own 2 feet. Welcome to Trash to Treasure with the Acorn Electron. This, of course, is not an Acorn Electron, it's a ZX Spectrum, a machine that was cleaning up in the entry-level home market. While Acorn had the schools market cornered, with its BBC branded computers, they wanted a machine with an entry-level price point to get their share of the spoils in that sector. The Electron is how they intended to do that. The first thing you'll notice about the Electron when comparing it to the competition is that it actually has a proper keyboard. The keys serve dual functions as indicated by the brown text on the front of the keys. These can be accessed by holding down the function key and pressing the relevant key. And very satisfying the keyboard is to use too. The lovely clacky keyboard and the dual function keys made it a breeze to program in BBC Basic, which is included in the machine's ROM, and is the same BASIC that we were using in schools at the time on our BBC Micros, so it gave the machine an educational slant, useful for marketing. The design of the machine is sturdy, utilitarian some might say, with a fairly mundane grid decal along the top, and textured plastics. It certainly wasn't about to appear in a modern art gallery, but it wasn't without charm. The design by Alan Boothroyd, who also designed previous machines like the Atom and the BBC Micro, aimed to put the Acorn brand in the limelight, having previously been tied to the BBC name while working with the broadcaster on its computer literacy project. The machine's ports go above and beyond what you might expect for a £199 entry-level machine. Expansions can slot onto the rear, something we'll look at later, and ports exist on the left-hand side of the machine, which are labelled underneath, so we'll just flip it over and take a look. The Electron offers us an Rf Modulator for use with a TV, a black and white composite output, an RGB monitor port, and a cassette port to load and save our programs. Compared to the competition where you'd typically get an Rf Modulator port or be confined to a manufacturer's proprietary monitor, I'd say that's a pretty good deal. The donated Electron came with a cassette deck cable, but alas, no cassette deck, so I'm having to source one of those. With the cables plugged into the left-hand side, your machine would look something like this, and the power cable would plug into the right-hand side of the machine. Power came in the form of a 19-volt, 14-watt AC adapter. 2 were included with the donation, and they sit in your wall socket as opposed to being a power brick that sits on the floor. You could in fact safely get away with using a DC adapter on this machine, owing to the regulation and rectification circuits inside the machine, which we'll see shortly. Looking at the size of these, they'd actually make a viable option for home defence. Now let's open up the Electron to see what condition it's in on the inside and take a tour of the internals. But first, a glance at the £4 million marketing campaign used to launch this machine.
First, let us examine one of the finest micros, the Electron from Acorn. It's as fast as a business computer, and it has a real keyboard. Pleasure to tune in, darling. Notice how it can grow and observe the color graphics. They would have warmed the heart of Michelangelo. You are familiar with Michelangelo, Mrs. Gale? That's a wicked rumour. Quite. Above all, the Electron uses the same language your girls use at school, BBC Basic, Colonel. Which home micro uses BBC Basic? You will write out the Acorn Electron 100 times. There's no better micro in its class.
Let's open her up then. The Acorn Electron was released in August 1983, having missed out on the all-important Christmas season. This was due to manufacturing problems with the ULA chip, which we'll see shortly. When opening the machine, we have to be careful not to break the keyboard ribbon cable. These cables can be extremely brittle after 30 years, so you should take extreme caution when opening a machine and when removing the cable on this, the Electron, and other micros of the same period. The Electron system board may seem familiar to you, and there's good reason for that. Acorn was founded in December 1978 by Harman Hauser and Chris Curry. Chris Curry, a former employee of 13 years, to Sir Clive Sinclair, which will no doubt have influenced Curry in his approach to designing micros, and likewise Sir Clive Sinclair. The Electron is split into two boards internally. On the right hand side we have the switching power supply, where we plug in our transformer from the wall socket. This passes both an 18 volt AC current directly to the expansion slot for add-ons to the rear of the machine, as well as positive and negative 5 volts to the system board and a common ground circuit. It's a very safe and forgiving power supply, reducing the risk of damage to the system board if the wrong supply is plugged in. This system board is an issue 2 UK board. Information is scarce, but I believe 6 boards were issued, but the general consensus is that they can be grouped into early and late model boards. In early boards the ULA chip is soldered onto the board, and on later boards they're socketed, perhaps to make repair or replacement of the infamous chip easier to manage. The RAM chips located here amount to 32 kilobytes of total RAM. To reduce cost, the RAM was spread over 4 64 kilobit chips and was addressable over a 4-bit memory bus. This is in stark contrast to the common practice of the time of using 16 kilobit RAM chips and an 8-bit memory bus. The result of this quirky decision was a machine that was cheaper to manufacture, with memory that was incredibly slow to access even for the time. Add to this the lack of dedicated video memory, meaning a chunk of this RAM would be used for the display and accessed by the ULA, and you had a recipe for a severely and quite unnecessarily crippled machine, all in the name of building this to a price point. The ULA, or Uncommitted Logic Array, just as in the ZX Spectrum, a single chip designed to perform multiple functions and therefore reduce the number of chips required in the build. Its design was led by Professor Stephen Ferber at Acorn and manufactured by Ferranti, the very same Stephen Ferber who is the original designer and hardware architect of the ARM chip. Acorn boasted that it was by far the largest custom chip anyone had put in a micro, with over 2,400 gates. It required 68 input-output lines, and was the largest chip on the Electron system board, bigger even than the 6502 central processing unit. The complexity of the chip thwarted pirates, particularly in Taiwan, where systems such as the Apple II with its clear layout and off-the-shelf parts were easy to copy. Its complexity, however, was also the source of problems, with manufacturing issues plaguing the early releases of the Electron and fingers being pointed by both parties as to where the blame lay. A failure rate of up to 25% was reported by dealers, with machines being returned and, most commonly, the source of the problem being lay at the door of the ULA. Its functions then were input-output, audio and video. The CPU is a MOS Technologies 6502 running at 2 MHz. It too was affected by the decisions made in the memory addressing. With the 4-bit wide memory bus, it required 2 accesses from the CPU to retrieve an 8-bit word. An 8-bit CPU which can only access RAM 4 bits at a time is obviously not running to its full potential. The CPU can access ROM at the full 2 MHz, but RAM at 1 MHz to enable it to share access to memory with the ULA. A modification was later discovered which allowed you to exclude the ULA from accessing the first 8 kilobytes of memory. This allowed the CPU to access that portion of memory at the full 2 MHz, and so by applying the hack and storing variables in that space, programs could be sped up significantly. Some think if this small modification had been made to the original machine, it would have had a greater impact on the market. The Electron's 32K ROM chip contains both the BBC Basic programming language and Acorn's Machine Operating System, or Acorn MOS. In later interviews, Acorn's co-founder Herman Hauser recounted that Bill Gates noticed the sales of BBC Micros, the precursor to the Electron, and tried to sell MS-DOS to Acorn, but Hauser considered that to be a downgrade to the Acorn MOS system, the Electron then narrowly avoiding MS-DOS and Microsoft Basic. The result is a single-tasking operating system, which is non-reentrant, meaning programs cannot be safely stopped and re-entered to continue execution at a later point, and was monolithic in nature, providing an extensive API to interface with all standard peripherals. Moving around the board, there are empty slots for such things as an additional 16K ROM and our master 16 MHz oscillator located in X1. This was divided down to give us our 2 MHz CPU clock speed. There are various other logic chips located around the board, such as these, which each contain 4 NAND gates, and this amplifier chip as we move closer to the circuitry for the audio and video output. The Rf Modulator is identical to that in the Spectrum. It takes a composite signal, modulates it as an RF signal, where your TV receives it and demodulates it to turn it into an image. While the Electron does have a composite output, it's black and white, but modifying this to be a colour image is as simple as shorting .LK4 on the board, which we'll explore in part 2. Or if you'd rather not modify the board, you can use a cable from the DIN RGB socket to a SCART plug. And that pretty much concludes our tour of the internals for today. I'll go ahead and strip the rest of the machine, in preparation for part 2, where we'll clean the machine, test it to ensure it's safe to turn on, including testing those power supplies, we'll make the colour composite modification, we'll play some games, and we'll talk about some of the expansions available for the system. But for now, here it is, laid bare, and ready for some TLC, so that this Acorn Electron can be enjoyed for another 30 years to come. If you enjoyed this video, please take a moment to like and subscribe to the channel, and come back for part 2 soon. Take care, cave dwellers.